Hi folks, we're going to take a look at page 40, number 2. So they give us this polynomial here and they tell us that when it's divided by x minus 3, the remainder is equal to negative 10. And they want us to find this unknown k value, which is a coefficient of x cubed. And then once we have that, they ask us to find the remainder when we divide f by x plus 3. Okay, so let's start with it. As soon as I see that a polynomial is being divided by a linear divisor and the only thing that interests me is the remainder, I know I don't actually have to go through with the division. We have the remainder theorem which can help us out. Okay, so remainder theorem says that if I divide by this linear, okay, the remainder of this division is just given by plugging in 3 into my polynomial. Okay, so I'm going to plug 3 into my polynomial, but I'm still going to have an unknown of k, but luckily they tell me that the remainder has to be equal to negative 10. Okay, so let's do that here for a. Let's plug in 3. Okay, and this expression here represents the remainder of this division. And we know that that remainder has to be equal to negative 10. Okay, and so now we can just solve for k. So here we have 81 plus 27k minus 9 minus 5 is equal to negative 10. So 27k is equal to, and I don't think I'm going to take any chances here, so let's get our calculator out. So what do we have? We've got negative 10. I'm just going to bring these three constants to the other side, so it's going to be plus 5 plus 9 minus 81. There you go, negative 77. So k is equal to negative 77 over 27. And I don't think that can be reduced any further. So what we have is that f at x is equal to x to the fourth minus 77 over 27 x cubed minus 3x minus 5. Okay, so now we know what the polynomial is. So in B, we can now find the remainder of this other division. Okay, here now I'm dividing this polynomial by x plus 3. So the remainder is just given by this polynomial evaluated at negative 3. Okay, so our remainder is just given by f at negative 3, which I can calculate pretty easily here. So we have negative 3 to the fourth minus 77 over 27 times negative 3 cubed minus 3 times negative 3 minus 5. So here this is still going to be 81 because it's an even power. And this is kind of going to work out nice here because I got negative 77 over 27, but negative 3 cubed is just negative 27. Okay, so we see that that's going to reduce. That's just going to become an addition. So here plus 9 minus 5. Okay, so let's just calculate that here. So what do we have? We have 81, so that's going to become plus 77, plus 9 minus 5. And that gives us 162. Okay, so again, we were able to determine this remainder without having to actually do the division, which actually I'm quite happy about because I think this 77 over 27 might have made the division a little more complex. Okay, so just to recap here, remember that when you're dividing a polynomial by a linear divisor, and the only thing you're interested or the only information you have to work with is the remainder, you're likely going to use the remainder theorem. Okay, easier than actually going through and doing an actual either long division or synthetic division. Okay, that's it for this one.